So I'm gonna explain about the multi-model system which I built it based on the session 10. Here's the high-level architecture. We got six uh, agents starting from the perception, critic, retriever, executor, decision, uh, all working in sync by a coordinator agent. It's also handled by uh, memory side, so that if you have a similar or same query being asked before, it goes and search using the FICE model, and then it gives you the response right there. It also has a MCPs, and which is handled by multi MCP client, which is further connected by multiple servers. Like if you have a web search or rack search or mathematical calculation to be done, it does it. Now let's understand about the core agent which I'm talking about. The perception is basically understand the situation. The decision agent basically plans and hand over the plans to executor to execute. The retriever goes and does the retrieving of the data, extracting the data if required through either through web or local document. And you have a critic agent at the multiple stages wherever you need. It basically try to maintain that there is no error, and this all agents and all the flow is maintained by coordinator. I'll quickly take you through the core uh, components of the solution. We have an agent system which initializes the multi-FCP, the memory system, all the agents and the coordinator. We have an agent session which maintain the session throughout the query, like multiple times it goes to perception, decision, try to get the right answer. So it maintains the session. Uh, uh, have those all called context ready in the memory. We also and then we have a memory, as I was talking about, which is basically using rapid first to store and find the similar query or same query which has been asked in the past. Let's talk about the agent. The coordinator agent, which I was talking about, basically determines the next agent to execute based on the current situation, and that is basically uh, gets decided by the previous agent right there. And it has a certain, so if we talk about like how it does that, if there's no perception, call perception. If and then based on the confidence, it called critic agent, that tell me what exactly it is. Then it stores the context, call retriever, then execution, executor agent, then it keep updating the further perception to analyze the result. Then you have a decision module which gets the planning done, and then finally it if the goal is satisfied, the coordinator terminated the whole function. Let's talk about like perception agent. So it's using Gemini 2 Flash model. It's basically takes the query and extract entities, intents, requirements from the initial user, and then analyzes the output of the executor also, and then determine the step was successful or not. Then it has like particular state to maintain, where it gives you the entities, the reasoning, the confidence score, and the goal, whether it has achieved or not. Talking about the decision agent, it basically takes the perception and context and all the tools which it has as available. It generates the structured plan to achieve the goal, and then the plan is basically either code or conclude. Then it after the planning, it basically dynamically replan everything whenever it's required. Then come to the executor agent. It's basically run the Python code. If let's say decision has generated a plan which is code, it basically takes the code and run in the sandbox. It can also call MCP tools whenever it is required, and then update the execution result. Then retriever agent is basically to go and find the details either from the local or web. Then you have a critic agent whenever basically to maintain that there is no error, there is no failure, what exactly happening, whether the result is right or wrong. So critic agent is being called by coordinator at multiple places to to find out whether the results are right or wrong. Then little bit about the MCP. We have a MCP server 1, MCP server 2. MCP server 1 is mostly about the calculation, and MCP server 2 is basically the RAG, where you have PDF, HTML images, and we're using FIS and nomic embedded text by Olama for embedding and searching by the FIS model. Then we have extract PDF module all in MCP server 2 itself. This is basically how the data is flowing. This is slightly complex graph, but it's fairly understandable. The user write the query, and main takes it, main.py, where the coordinator agent is there. The coordinator pass it to the perception. If you see that here, perception, and then perception, and it also goes to the retriever. It gets the context, and then perception pass it to the decision. Perception doesn't pass to the decision. Perception gives the their feedback and the basically data. The coordinator calls the decision. So basically same what we discussed right in the beginning. Little bit diving deep into the execution flow. So let's say if we have to ask what is capital of France, very simple. Let's say this is stored in one of the document. What happens? In the step 0, it initializes all the state of the agent by coordinator. Then perception takes it and says that, okay, what is capital of France? And it get all those entities, France, capital, what is the intent of the user, which is called fact retrieval here. And then it calls call retriever. Okay. Then retriever goes to the local search documents and finds that France is the capital. Then it writes you the context that Paris is the capital of the France found in the local docs. The planning agent takes it, and then it says that it's conclude because it has already found. It doesn't need to plan a coding plan for executor, and it just that gives you the answer. The basically and then output as a executor takes it and conclude it. Okay, it goes back to the main, and then it returns the query response. Okay, this is a little bit about the function level, that how exactly it is happening. If you look about the retriever, it's process, and it's do search local or search wave, which is again it has to call the MCP. Then perception, it calls generate content. So basically it has certain input as a query. Then it calls LLM module to get all the entities and the basically what it has to feed front, and then decision same. It uses the LLM to does the job. So this is basically the function level details. Diving a little bit into the reasoning part of it, why are we doing it? So by splitting the agent into specialized role, the system avoids the a God object like anti-pattern, right? A different work for a different agent to be done. Then you have a one session to be which is being maintained, history, plan, perception, all the context. Then you have a dynamic planning. If anything fails at any moment, the critic has different feedback. It basically takes you to the different planning. It makes you different planning. You have an MCP for extension. If you have like more such tools which LLM doesn't handle, you can always integrate. Right now I have 2. Then you have RAG, and then you have self-correction, which is as a critic agent. So this is overall the whole architecture. Let me run this, and then probably we can see how exactly it is working. So I'll quickly run this. No, so this is how it goes. Right, I'm just clearing the memory so that any previous search does not have anything. If you see here, it listed the servers, the MCP server. It listed the tools it has, and it finally is saying that what's your query. So let's take one of the query from here. and let's take the very first one. So see what exactly it is happening is that it first did the memory search and it says that no cache found, and then it moved into perception layer. The perception layer said that it's asking about India, ASCII, some of the exponential, and then it goes to retriever. Retriever tried to search through, and then it basically it's a calculation, so it does not have anything. And then it comes to yeah. So I mean, retriever layer came back saying that it's a traditional knowledge, and decision took that input, and then it planned three. So find the ASCII value of the character in India, so and so, convert the ASCII value, and then finally output the final result. Then it takes the first step zero as a action, and then hand over to the executor. The executor comes back and say that this is the answer. Then perception takes this value, and then it says that word process and the sum of the exponential calculated resulting into this, and this is directly answers the initial query. And since this is the directly, then it comes here. Then here we found the ASCII value. Okay, no, sorry. So here now it's saying convert exponential, the ASCII values to exponential, and conclude. So it took it and then it just concluded it. So yeah, I think yeah, it's concluded the answer right here. And now let's say if we again search this, it will go back to memory and then directly give you the answer right here. It does not have to do it all again. Let's search another query and let's go to this one. So the earlier one was mostly about mathematical part, and here it is says that okay, no cache found. Perception layer gives you that user is asking about the information. The retriever finds some details. Retriever has in the local document, it gets some details, pass it to the decision creates two plan, summarize the information about Don, and so because it already saw that in the retriever has got the context, and it's basically summarizing it. So Don Transport and has argued for the use of the open source and so and so. So this is what the architecture is all about.